Hello guys, welcome back to JEE Physics, JEE Mains Physics previous year's questions discussion session. So specifically we are discussing 9/4/24. So 9th April 24th morning session in a few two parts. Previously we have discussed a few questions, and especially in the last session we have discussed the 12th based questions. In this session we discuss 11th based questions. Okay, I hope you're ready. So if you come across any questions, just you can drop a message while discussion. If you if any just I don't think more students are following the live. So after this, so some of the students may go through. While going through, yes, you can start trying yourself. Okay, so try to understand how to do physics questions. Number of times, as I have told, you have to read the question first. Doing physics questions is very easy and very simple, guys. Physics, many questions, many students, number of times usually used to tell that physics is difficult, but as many of the students will ask how to work out the questions, and some students will say that so we are not able to understand which formula to use and how to start doing the questions and all. So these questions will not come from the students who are actually having very good practice. So those who are not having that much rigorous practice may have this. So I am not pointing out that in a negative way. So you have to start practicing. How to start practice physics questions and numericals is, first read the question and write down the given data, then write down what you are asked to find. Very simple thing. If you are able to understand this, that means you are in positive track. You have already got some good practice, enough practice. If not, you have to do more and more practice, guys. Then you have to think about the formula which relates the asked parameter and given data. Then you can substitute the values and simplify, calculate. Then you will get the answer. While doing these calculations, sometimes you may get a 2-step or 3-step processes and all. Direct substitution based questions also you may get. If mass of a particle is given, and if it, for example, if it is moving with an acceleration of, if a mass of a particle is 10 kg and if it is moving with 1 meter per second square acceleration, what is the force acting on the particle? If you are asked, F is equal to m into a, you can answer directly. So this kind of direct questions you may not get. So sometimes you will get, not sometimes, many number of times you may get this kind of questions also. Sometimes 2-step, 3-step basic questions also you will come across. So to work out those kind of questions, we need more practice and some idea of related concepts. That's it, right? So let us start with this now. The first question is, the question is, a particle moving in a straight line covers half the distance with the speed 6 meters per second. The other half is covered in 2 equal time intervals with the speeds 9 meters per second and 15 meters per second respectively. The average speed of the particle during the motion is, so almost many of those who are going through this got some idea just by looking at this question itself. Average speed calculation, you have to recollect back the special cases which you have discussed, which you have gone through during discussion of average speed calculations in motion in a straight line chapter. So then write down the given data first here. See what is given. A particle is moving in a straight line, covers half of the distance with a speed of 6 meters per second. So half of the distance means you have to consider the total journey. You can try to draw a pictorial representation for this quickly so that you can understand a little more easily. So let us say this is starting point A and ending point B. So between this, if you draw a line, yes, exactly half of the distance. If you say total distance is s, or for convenience let us say it is 2s, total distance is 2s, half of the distance is s. So this half of the distance, the particle has traveled with the speed of, you can take v1 is equal to 6 meters per seconds. The other half is covered in two equal intervals. So this is first half, remaining half. So this is s means this is s by 2. So this remaining is the entire thing is s actually. So the other half is covered in two equal intervals, not two equal distances. So we shouldn't take s by 2. Two equal intervals. That means, so here it has to cover this distance with the speed of 6 meters per second. It may have taken some time. You can take it as v1. This it has taken, it has traveled with a in two equal intervals, t and t. So you can take this as t2 equal to t, and this interval t3 equal to t. Okay. Now, and also it is given that two equal intervals with the speeds 9 and 15 meters per seconds. So here it has traveled with the speed of v2 is equal to 9 meters per seconds, and at this time interval, during this time it has traveled with the speed of v3 is equal to 15 meters per second. Then the average speed of the particle is average speed. Write down what is average speed. So immediately you have to write general formula for average speed is, you know that v average always is equal to total distance by total time. Average speed, average velocity means total displacement by total time. Velocity vector related parameter displacement you have to use, displacement by time. Average speed, if you are asked related term called distance, you have to use total distance. Total distance by total time. Total time. So total distance, of course total distance is 2s, have to be 2s by here total time. So let us take in terms of time intervals. T1 first half it has traveled for T1 time. Next half distance it has taken into equal intervals, that is T2 and T3. T plus T you can take. So we can take it as a T1 plus T2 plus T3. Like this you can take. Now T2 equal to T3 equal to T. So you can also write it as 2s by T plus 2T. Right. But here T values are not given numerical values. V1, V2, V3 are given. The speeds with which they have traveled during T1. This is T1 guys. During T1 time, during the first T, then this second equal interval of time. It has traveled at this different speed. These are given. Right. Then how to calculate? Yes. One sec, guys. Right. So you have to consider as you have taken the total distance is what 2s, right? Even the distance also is not mentioned. So you have to, then how to take in terms of the given parameters is the question. So here we have to say as in general the distance traveled, speed, if s distance has traveled with 6 meters per second, let us say for T1 time, then what is T1? As it is nothing but s by T1 From this you can write, this implies T1 is equal to S by V. So the distance is just V is 6. V is 6. From this you can also say S is equal to 6, S is equal to 6 V, 6 T1 also, right? So but so let us skip, then we have to just simplify this step by step. And this is for the first half distance, yes, distance. That is we can mark some letters here. This initial point is A, final point is B. This point you can mark it as C, this point you can mark it as D, something like that. You can give some names to this. Okay, right. Now, so T1 is equal to S by 6. Then what is T2, what is T3? Similarly, as V is equal to S, we don't know what is the distance traveled during T2 time. So you can take some distance. What is given there? Remaining entire half distance it has traveled with the time during time intervals T2 plus T3 actually. So here let us take for CD during CD duration, T2 time it has taken. So here we can take the distance so the entire remaining half distance, that is from C to B, that is equal distance. Yes, you can take the, it has taken two equal intervals, t plus t, 2t it has taken, right? So you can take from this but with the different speeds it has traveled. So that relation between here S is also equal to S is equal to V into T2. Right? Yeah. So here how to work out this is, as we know, average this you can take it as equation 1 here, and as total distance by total time, 2S by T1 plus 2T. Here T1 is S by 6, T1 is S by 6, T2, but we don't know the total T1 plus T2, that is 2T is during 2T time it has traveled that remaining S distance. Okay, this we have to take little differently. So for working out this particular part, just we have to make use of this relation, one simple relation here, that is, see, from this you can also take S is equal to 6T1, S is equal to 6T1, but for the remaining the entire half distance, that is S, it has taken two equal intervals of time. So you can take S is equal to, distance is equal to velocity into time. It has traveled with 9 meters per second for T time, and for again another T time it has traveled with 15 meters per second. So as S is equal to, we don't know what is the distance traveled during the second half, we can take it as S2 plus S3, let us take. So it is in terms of velocity V2T, V2T2 plus V3 T3 have to take, but T2 and T3 are equal to T, so you can also take V2T plus V3 T. So this you have to take, you can take it as V2 is what, 9, V3 is 15, so 9T plus 15T is equal to 24T. So this you can take it as S is equal to 6T1, you can take it as 2, equation 2, and this you can take it as equation 3. So equation 3 says s is equal to 24t, equation 2 says s is equal to 6t1. This is t1, this is t2, but both are equal to s only. So from 2 and 3 you can take what is this, 6t1 is equal to 24t. On simplifying this to 6 1 6 4s, you can write this implies t1 is equal to 4t, right? This you can take it as 4. Step for understanding purpose, step by step. Now what actually you want? V average. Now equation 1, look at equation 1. So if you substitute this in equation 1, you will get the answer. What is that? V average is 2s by t1 plus t2. T1 is 4t, t2 is 2t. So you can so this implies R1 and from 1 and 4, this implies you can take V average is equal to 2 into 2s. Actually you can take 2s only. Let us take 2s. 2 into s by t1. T1 is 4t plus 2t, that is 6t. 2s by 6t, but s value is not given, so s value also you have to substitute in terms of t only. S is also equal to 24t, so 2 into 24t by 6t. So now on simplifying this further, what you will get? 6 1s 6 4s. So under t gets cancelled. 4 2s 8, it is 8. So therefore V average is equal to what? 8. Speed, average speed unit should be meter per seconds. So this is how you have to do this kind of questions, guys. I hope the explanation is clear step by step. So first, as you are asked to find average speed, just let me brief out once again. Average speed is equal to total distance by total time. If you consider total distance is 2s, because we are dividing the first half distance, second half distance, like that, let us take it as 2s. You can if you take s also, you can take s also. If you take s, then first half distance will be s by 2, second half distance, that is a cd in the diagram, should be s by 2. That way also you can take, nothing wrong. For convenience you have taken total is 2s, then first half, that is AC distance, is s, then B distance is s. Okay, in the figure this will be s, like this. Now first half distance, total distance is 2s, but total time is, it is given that first half distance it has traveled with 6 meter per seconds. That means it has taken some time. That time we are taking it as t1. The next remaining half distance it has traveled during two equal intervals of time, t and t, with 9 and 15 meter per second respective speeds it has traveled. That means it might have covered some distances, some s2 and s3. That s2 plus s3 should be equal to s. So because average speed is total distance by total time, so total distance is 2s, total time is t1 plus t2 plus t3. That we have taken as t1. T2 and t3 are equal to t, so t plus 2 is 2t. That we have taken as equation 1. Now t1 to get here, we have taken just by using the definition of a speed equal to distance by time. For the first half, the distance is s, so t1 is equal to s by speed is v. V is given as 6. So from this we can write s is equal to 61, equation 2. Next half distance is taken as s is equal to s2 plus s3. It have traveled some unknown distances s2 and s3, where during those distances it has they have taken two equal intervals with some known speeds the particle has traveled. So we have written s2 plus s3 as v2 t2 plus v3 t3, v2 t2 plus v3 t3, right? So here t2 t3 are equal to t, okay, but v2 v3 are different. So if you substitute those v2 v3s, then we'll get as v2t plus v3t is equal to, v2 is 9 meter per second, so 9t, v3 is 15 meter per second, so it is plus 15t, that gives 24t, equation 3. Next, as this 2 and 3 gives s only, 2 gives s equal to 61 and 3 gives s equal to 24t, we have got t1 value in terms of t, that is t1 equal to 4t, as we have taken this as equation 4. Now by substituting this t1 and s value also in terms of t, T1 in terms of T, S also in terms of T. Then after simplification we got average speed, as average speed is 2s by T1 plus 2T from equation 1. So we'll get 2s by 4T plus 2T. T1 is 40 plus 2T, so it is 60. So 2s by 60. But S in terms of T is why we have to substitute, because the final value should not be, if you see here the options they are given in numerical based values, so you have to eliminate the unknown parameters. So if you represent S in terms of T, then it can cancel out. Otherwise you have to take T in terms of S. Either way you can take, no problem. So 2 into S is 24T by 60. Then on simplifying it you will get 8. So which option is the right one? 8, fourth option. Yes, so the fourth option is the correct one. Next question. Yes, I hope it is clear for you guys. Let us see the next one. Yeah, let us see here. The question is, a sphere of a relative density sigma and a sphere of relative density sigma and diameter d has a concentric cavity of diameter d. Cavity diameter is small d. Then the ratio of capital D by small d, if it just floats on water in a tank, is. So here what you have to understand, what is given and what you are asked to find, you have to observe. So this is from the chapter Mechanical Properties of Fluids, and specifically the concept is buoyancy. See, I can say, in case of buoyancy, there are 3 conditions you have to remember immediately if you come across that floating case. When a body, when the density of the body is more than density of the liquid, it sinks. It is equal, density of the body is equal to density of the liquid. It floats at a point wherever you immerse and keep it. And if the density of the body is less than density of the liquid, then it floats on top. Yes, here you have to just remember that relation, and also you have to remember what is this? Archimedes principle. It says that whenever you immerse a body in a liquid, the volume of displaced liquid is equal to volume of the immersed portion of the body. So based on that and the law of buoyancy, you have to calculate this. It's simple. So if you are not able to recollect back that concept, go and read that concept as a simple concept, then you can try. That is what you have to do. Sometimes if you are not able to understand how to do, you have to go through that concept. And come back and try the question once again. Right, now let us see here what is given. When the body is floating, means, say, let us say this is a beaker, something like this. There is a liquid and there is a sphere. The sphere is floating. Means, so whenever there is a sphere of density rho is there, means it will have some mass, and of course that because of mass it will have some weight. W is equal to m into g. If W is more, if it is floating, means there will be a force called upthrust force will act on this. Upthrust force is also called as buoyant force. If weight is more than upthrust force, it will sink. It is floating, means both are equal. That's what you have to understand. So here weight for floating, from the laws of flotation, for floating, weight should be equal to upthrust buoyant force, right? Where what is weight? M into G. What is this? Weight is mass of the object into G. She should be equal to buoyant force. Next, yeah. See what is here Mass of the object is given m into g. M is mass of the floating body, sphere here. It is not given, but density of the body is given. In terms, and options are also given in terms of density only. So you have to everything you have to just replace in terms of densities, and you have to simplify. Then you have to find out the ratio of capital D by small d. So here mass of the body is in terms of density. As you know, density is equal to, you have to remember a simple relation, density is equal to mass by volume. Density is equal to mass by volume. Here density of the body is equal to mass of the body by volume of the body. So here mass of the body m is equal to density into volume. Density of the body, relative density of the body means density of the body by density of the liquid, especially density of the water. Density of water, so usually we take it as 1 unit in CGS units and 1000 kg per meter cube in SI units. So here you have to consider m is density into volume. Density of the body is sigma. Volume of the body is 4 by 3 pi r cube. Here r is radius. R is not given. Diameter is given. That means you have to take it as a d by radius is diameter by 2. So d by 2 whole cube is mass into g is equal to buoyant force. Upward force, upthrust force is called buoyant force. Buoyant force is nothing but the, again, force is buoyant force is also equal to mass into volume. So here, but in this case you have to write it as mass is mass of the buoyant force in terms of density and volume. Density, buoyant force will act due to the liquid, so you have to take the mass of the liquid which is exerting the buoyant force on the volume of the immersed portion of the body, on volume of immersed portion of the body. So here we have to take the mass equal density into volume. Density is in CGS unit, if you take it as 1 unit, volume is 4 by 3 pi into so here one thing is given. Right, wait guys, one minute. I think we have taken a small difference. Weight, if this is not solid sphere, it is having a concentric cavity. So because of that, some the what is that weight during the mass part due to the cavity you have to subtract. So this we have to just a small modification to do. Excuse me, here small modification. Because of the cavity you have to take 4 by 3. So this is 4 by 3 d 4 by what is that, mass of the total sphere minus mass of the so volume of the total sphere minus volume of the cavity you have to subtract. That will give you the corresponding mass of the sphere. So density into volume, total volume of the sphere minus volume of the cavity will give mass of the sphere. So that gives sigma into 4 by 3 pi into capital 2 whole cube gives the total volume of the sphere minus sigma into, here you can take sigma out anyway, and 4 by 3 also out. 4 by 3 the volume of the cube cavity means small d by d is the diameter of the cavity, d by 2 whole cube. So sigma and 4 by 3 if we take out common, then you will get this is mg part. So better let us take separately, then afterwards we can equate this. Let us say this is equation 1. Here this is w, where w is this. So this, on simplifying further, you can write is equal to 4 by 3 pi into d by 2 whole cube is d cube by 8, small d by 2 whole cube is small d cube by 8. 8 is common. You can then you can write d cube minus small d cube by 8 into sigma into g. You can write here sigma into g, that is w. You can take This is equation 2. Whereas buoyant force, and buoyant force Fb is equal to, buoyant force is the upthrust force is equal to, of course this is also equal to m into g only, but m is density of the liquid which is exerting the upward force, density of liquid into volume of the liquid which is constituting. So you can take it as volume. So volume of the liquid displaced, volume of liquid displaced in this case, even though it is having cavity inside, whatever it is, how much volumes of the sphere in immersed, that much volume of the liquid will displace us. So we will take the total volume of the sphere is nothing but the total volume of the displaced liquid. So it is equal to sigma of liquid, you can take it as 1 into volume is 4 by 3 pi radius of the the sphere cube. Radius of the sphere is diameter by 2, d by 2, whole cube is d cube by 8, d cube by 8 you can write. So into g into the sigma into volume gives mass, into g will be the F buoyant force, so into g you have to take here. So this is Fb, you can take it as equation 3. So 2 and 3 if substituted in equation 1, because when the object is sphere is floating, these two should be equal. Okay, now if you substitute this in equation 1 and simplify, then what you will get? Yes, you can do this quickly by yourself. W equation 1 implies W equal to Fb. W is nothing but 4 by 3 pi into capital D cube minus small d cube by 8 into sigma g should be equal to 4 by 3 pi into capital D cube by 8 into g. So here small g cancel, 4 by 3 pi gets cancelled, then we will get capital D cube minus small d cube by 8 is equal to d cube by 8 also gets cancelled, then we will get is equal to d cube. Miss anything else? Just you can cross check this once. So here this d cube, if you bring under densities, sigma is here, right? Sigma is there on left hand side, on right hand side density of the water has, you have taken it as 1, so this is into sigma, you have to take this into sigma. If you take now what you want actually is capital D by small d. For that purpose we can take the capital D cube to the left and send sigma to the right, separate the terms, then you will get capital D cube by capital D cube, or d cube minus small d cube by capital D cube. The further can be expressed like this, minus d cube by capital D cube is equal to 1 by sigma. So this d cube becomes 1. So now again you can write it as small d by capital D whole cube minus d cube by small d cube by capital D cube can be expressed like this. This if you take it on the right side, it becomes plus, it is equal to 1 minus 1 by sigma is equal to sigma minus 1 by sigma is d by d whole cube, but we want d by d, so that the cube if you send onto the right hand side, it becomes power 1 by 3. So sigma minus 1 by sigma power 1 by 3 is your answer. So this implies small d by capital D is equal to sigma minus 1 by sigma power 1 by 3. If this option is not there, you have to take the simplified form. What is that? 1 minus 1 by sigma power 1 by 3. You can check the options and can take accordingly. Sigma minus 1. Nice. What is that? Capital D by small d by capital D are asked to find. Capital D by small d, yeah, so you have to be a little careful. Small d by capital D is this, guys. So then, so here itself we can take, this is sigma minus 1 by sigma. So whereas if you are asked to find the capital D by small d, you have to take the reverse way, that is sigma by sigma minus 1 power 1 by 3. Yes, that also depending on the requirement you have to cross check. Both options may be there. If you in hurry, if you take in the wrong answer, you lose the marks. You will feel like you did correct, but you will lose the marks. You have to carefully take the options. Sigma by sigma minus 1 whole power 1 by 3. So option 1 is the right one. So this kind of questions you have to little carefully. So go through once again properly and try step by step, guys. Next question. I hope it is clear for you, and let us get into the next question. So you can pause and you can note down the points and try once again. If you have understood, it is well and good. If not, try once again. Right. Next question. This is a very simple one. This kind of questions we might have practiced a number of times. The dimensional formula of latent heat is dimensional formula of latent heat. So you should able to get the formula for latent heat, then write the unit of this in fundamental units form, then write the dimensional formula based on the fundamental quantities or units involved. So what is the formula which relates latent heat? Latent heat relates with this formula in mechanical properties of thermal properties of matter, while discussing the transfer of heat part. When if you supply heat, so that the heat supplied is used, so the supplied heat is used for raising temperature without change of state, then that heat supplied can be expressed as ms into delta theta, and delta theta is change in temperature. Whereas if you supply some heat to a body and the supplied heat is utilized for change of state, then heat is equal to m into L. So here if you are asked to find the dimensional formula of specific heat, you have to use this formula. For latent heat you have to use this formula. Now this formula is what you have to make use for latent heat. So latent heat L is equal to Q by M. So dimensional formula of latent heat is different. Specific, here S is specific heat capacity, here latent heat capacity is L. So units of both specific heat and latent heat are different, and dimensional formula are also different. Now as L is equal to Q by M, latent heat L, where L is equal to latent heat, L is equal to Q by M, where Q is heat, M is mass. Heat is nothing but energy. Heat energy we can call it as heat energy, where Q is what? Heat energy, and M is mass. Heat energy is nothing but energy, a form of energy. So we can consider is energy itself, and you should remember that the units and dimensions of energy and work done both are same. So if you remember so this, then no need to just worry, directly can write. So it is equal to, so dimensional formula of specific latent heat is equal to dimensional formula of work done by dimensional formula of mass. Work done is force into displacement. Here you can write energy, because energy is equal to work done, and work done is equal to force into displacement. Force is mass into acceleration of displacement. Then you can, if you didn't remember the dimensional formula of work, try to write the unit of work done in terms of fundamental units form. So force is mass into acceleration, so kg. Yes, acceleration is meter per second square. Meter into displacement unit is also meter, so you will get meter square per second square is the unit of work done or energy. Yes, in fundamental units form. So dimensional formula of this should be m power 1 L power 2 T power minus 2 by mass is a fundamental quantity. Its dimensional formula is L power 1. So on simplifying, you will get dimensional formula of latent heat is equal to m power 1 L power 1 T power minus 2. Is it m power 1? Mass? Sorry, oh, this is mass, guys, not length. Mass, not L power 1, m power 1. Sorry, it is m power 1, m power 1. So m power 1 gets cancelled, so we'll get m power 0. Yeah, m power 0 L power 2 T power minus 2 is the dimensional formula. Yes, m power 0 L power 2 T power minus 2, or simply L power 2 T power minus 2 also you can get. L power 2 T power minus 2 also you can write. This is how you have to write the dimensional formula of any quantity. So generally dimensional formula of constants, universal constants will be asked. You have to remember this: Planck's constant, universal gravitational constant, like this kind of quantities, right? That's it. I hope it is clear for you. The next question is this. Yes, see, the question is the volume of an ideal gas within bracket gamma equal to 1.5. What is gamma? Adiabatic constant of the gas is 1.5, given gamma is equal to 1.5. What is the gamma? Adiabatic constant. Adiabatic constant, or you can say ratio between specific heats also. Gamma equal to Cp by Cv. Immediately you should be able to understand. Yes. Yes guys, here this meanwhile I would like to convey that JEE mains April session results are out, so you can go through one link. Just that link I can tell. Just what is the JEE? One second. HTTPS. You can go through this link. JEE mains results are out. You can go through this. JEE mains. Here let me write separately. JEE mains April session. April results are out. Results are out. You have to go to this link, guys. The link is https://JEE main session 2. Yes, JEE main session 2 dot NTA online dot in slash front end slash web slash scorecard slash index. Try to go through this, then you can find the results. Okay, so this, copy it, and you can click on the link. Just you can type this in Google also, then automatically the link will be connected to that. Try your results, finding your results, and you can get your scorecards. Yes guys, one sec. Yes guys, right. Let's go to this next. So the volume of an ideal gas whose gamma, that is adiabatic constant, gamma, which is nothing but a ratio of specific heats Cp by Cv is equal to 1.5, is changed adiabatically. Right, is changed adiabatically from 5 liters to 4 liters. What is this 5 liters to 4 liters? Volume is changed adiabatically from 5 liters to 4 liters, means volume changes from initial to final value. Initial volume is given, final volume is given, gamma is given for the given gas. Then the ratio of initial pressure to final pressure is, yes, simply you have to write down the given data and you have to relate the formula. So as a given, you can take quickly and try yourself. Given gamma is equal to 1.5 and 1.5 can also be written as 3 by 2. So based on based on your requirement, you can write 3 by 2 also for simplification purpose. Otherwise you can take 1.5 only. And V1 is 5 liters and V2 is 4 liters. We are asked to find ratio of initial pressure to final pressure. We are asked to find ratio of initial pressure to final pressure. So P1 by P2 is equal to what? So what is the relation, the formula for adiabatic process in terms of pressure and volume? Especially for adiabatic process, you have different equations in terms of pressure and volume, in terms of temperature and volume, different formula you are having. You have to remember all those. So now what is the gas equation? Ideal gas equation is PV equal to nRT. PV is equal to nRT or mu RT. In representation you can use. Here n represents number of moles. For 1 mole, PV equal to RT. For isothermal process, temperature is constant, so you can write PV equal to constant. For adiabatic process, you have to take the gas equation is PV power gamma is equal to constant in terms of pressure and volume is this, right? Whereas in terms of temperature and volume, do you remember what is the adiabatic gas equation for adiabatic process in terms of temperature and volume? TV power S TV power gamma minus 1 is equal to constant. TV power gamma minus 1 is equal to constant in terms of temperature and volume. Pressure and volume, PV power gamma equal to constant. Here this we have to use. When you say adiabatic process, immediately these two equations and in terms of volume, what you call pressure and temperatures, the other relations also you have to just recollect back once. So now we can rewrite this as P1 V1 power gamma is equal to P2 V2 power gamma, which is equal to constant. So now we want P1 by P2. So let's write it as P1 by P2 is equal to V2 by V1 power gamma. V2 power gamma by V1 power gamma. So V2 by V1 power gamma. So it is equal to, what is V2? 4. What is V1? 5 power gamma is what? 1.5. So is there any such what kind of options are given? So based on this options you have to simplify. You can write it as 1.5, gamma is 1.5, right? So you can also write it this as 3 by 2, as I told. Based on requirement you have to simplify this further. This can also be expressed as, you can also write it this as 4 by 5 whole cube whole power half. Is the power you can multiply. So this is something like x power m whole power n is equal to x power m into n. Powers will be multiplied. So in this way you can write, or x power mn can be expressed as x power m whole power n. In this way you can rewrite like this one here. So now we can simplify further as 4 cube by 5 cube. Power half is root. So this you can also write it as, now here you have to simplify based on options guys. 4 cube is 4 into 4 into 4, or 4 into 4 square by 5 into 5 square. Yes, 4 into 4 square by 5 into 5 square, or 4 by 5 into 4 by 5 whole square. Yes, whole power half, that is the root. This further can be expressed as power half means root entire thing. If you write under root, then we will get 4 by 5 whole square comes out and it becomes 4 by 5 into 4 by root square root of 4 by 5. So if you observe the options, is there any such kind of options? 4 by 5 root 4 by 5? No. That means further you have to simplify. Again, root 4. What is root 4? 2. So 4 into 2 is 8. 8 by 5 into 1 by root 5. You can write this. So P1 by P2 can be expressed in any of these forms. Based on the requirements you have to simplify. So is there any such option? 8 by 5 into root 1 by 5? 8 by 5 into root 1 by 5. So here 8 by 5 root 5. So 8 by 5 into root 5 comes in denominator, so root 5. This is your answer. So that is how you have to simplify. So here, which option is right? Third option is right. I hope it is clear for you. Next, let us get into the next question. This question, see, the next question is: an astronaut takes a ball of mass small m from Earth to space. He throws the ball into circular orbit about Earth at an altitude of 318.5 km. From Earth's surface to the orbit, the change in total mechanical energy of the ball is x into capital G capital M into small m by 21 R capital R or RE. Capital M is capital ME is mass of Earth, capital RE is radius of Earth. So then the value of x is, what is the value of x provided? Take RE, radius of Earth is 6370 km. Usually approximately we will take radius of Earth is 6400 kilometers. 370 approximately we will take it as 400, so 6400 kilometers for normal calculations. But in this particular case you have to take this value, then you have to calculate. So so this kind of questions you have to do properly with the calculations also. So what you are asked to calculate here? Yes, what is given and what you are asked to calculate here? An astronaut takes a ball of mass small m from surface of Earth. Just you have to understand the scenario is just quickly. Earth, center of Earth is this, radius of Earth is capital R, and mass of Earth is capital M, base of Earth. From here, an astronaut takes a ball of mass small m from Earth means surface of Earth to space, to somewhere here to space, and he throws this ball into circular orbit. He throws this ball into a circular orbit, like so this kind of orbit. Throws this small m into this after taking this to some height h. Okay. Now, so he has a circular orbit, ball into circular orbit about Earth at an altitude of 318.5 km, means height at a height of 318.5 kilometers. This is altitude means height. Okay. Yes. Alright guys, now the point is from Earth's surface to the orbit, the change in total mechanical energy of the ball is change in total mechanical energy. So on surface, what is total energy? Total mechanical energy or total energy. Then at that height, what is total energy? Then what is the difference between this total mechanical energy? So you have to remember total energy or total mechanical energy, gravitational total mechanical energy. So this similar to what you call in atoms and nuclear chapter we will study. When an electron is revolving in an orbit, it will possess some potential energy, kinetic energy and total energy. These are kind of related ones. So can simply can compare and remember this kind of things. Okay, so now in this case, what is total energy? Total gravitational energy. So T is equal to, we have to remember that T is equal to minus capital G, where capital G is universal gravitational constant, into capital M small m, G mm, capital G m1 m2 also you can take G m1 m2, where m1 is mass of Earth capital M and mass of the body small m, G mm by R. You can take R is the distance from center. With respect to center, we will consider small r also can take. Small r is equal to capital R in this particular case. So on surface, we can take it as initial total energy of the small body. Okay. So now we can take this is equation 1. When it is taken to a height of 318.5 kilometers, that means to a height of h, then the radius of the orbit becomes capital R place. We have to take r plus h. Okay. So then what you will get? So here just they have to take 318.5 kilometers, right? This for calculation purpose, just you should how can you take like this, you may ask. This is based on your practice you have to take. So for h is 318.5 kilometers, but radius of earth is capital R is equal to 6,370 kilometers. So here this h approximately can be taken as capital R by 20. You can take this 6,070 by 20. If you take, you will get approximately this, that is 637 by 2 is 318.5 kilometers. So that is how you can take h is equal to R by 20. That you have to substitute in this particular case. This finally, when you are taken to a height h, the distance radius of the orbit becomes capital R plus small h. This further can be expressed as minus g m by capital R plus h is R by 20. You have to take. Okay. This on simplification. So 20 R plus R is 21 R by 20. So this on simplifying, so this is equation 2R. Of course you can take it as 21 R by 20. It is equal to minus G m small m. You can take what is this, 20 gmm by 21 R, equation 2. On taking the difference between this, okay, so any other condition is given here, you can take it properly. An astronaut takes the ball of mass small m from earth to surface and he throws the ball into a circular orbit about the radius at an altitude of 318.5 kilometers. From earth's surface to the orbit, the change in total mechanical energy of the ball is x into this, x into gmm by 21 re. The value of x is, right, the change. So now we have to take the change. Delta capital T is equal to Tf minus Ti. So take the difference. Then on the surface of earth, it is minus gmm by r. So on final energy is when the object is thrown onto circular orbit. So we have to take it as at satellite. So here we have to just take small correction here, that when the object is revolving around the earth, and if you consider it as earth satellite, the total mechanical energy of the satellite can be taken as minus gmm by 2 into the distance. Here also you have to take 2 into the distance. So here also again 2 into this in denominator you have to take. Then after simplification you can take this further as this as 10 it will become. So the simplified form, further simplified form is this. It is equal to minus 10 g mm by 21 r. This you can take it as equation 2. Now the difference between them is final energy is minus 10 g mm by 21 r, minus of minus plus, what is the Ti? Gmm by r. So Gmm by r. So this is positive term, this is negative term. So Gmm by r is common. If by taking this out, you can write Gmm by r out. Positive term as 1 minus 10 by 21. 21 minus 10 is 11 by 21. So therefore, the change in total energy, total mechanical energy of the body is what is that? 11 by 21 Gmm by r. This is the one. So in the option it is in the question it is given that it is equal to x times gmm by 21 r. So what is the value of x is the question. So in place of x here, what do we have in place of x? Yes, here we have in place of x 11. So this implies x is equal to 11. So it is a numerical based question, guys. Right, that's it. So this is how we have to work out this kind of questions. So the total mechanical energy of a body when it is in static condition on surface of earth is minus gmm by r. When it is revolving around the earth, so total mechanical energy of earth satellite is minus gmm by 2 into r, where r is radius of that satellite. Here the object, it is nothing but capital R plus h. That you have to take. and simplify the conditions accordingly. That's it. I hope it is clear for you. Then the next question is, right, this one. What is given here and what you are asked to find? Let us see. Right. So it is given that a sample of 1 mole gas, at temperature T is adiabatically expanded. Adiabatic process, already one question we did. This is also based on adiabatic, but there, in terms of when the volume is changed, then you are asked to find ratio of pressures. Gamma is given. Here, what is given and what you are asked to find? Let us see. A sample of 1 mole of gas, number of moles, N or mu, any symbol you can use, is equal to 1 of gas at temperature T. So temperature T is equal to constant, at a given temperature. So at temperature is constant, it is not adiabatic, it is isothermal. So here at a temperature, so at a given temperature, temperature T is adiabatically expanded to double its volume. So how to double its volume means initial volume V1 is equal to V and V2 is equal to 2V. Okay, then if adiabatic constant for the gas is gamma equal to 3 by 2, if gamma is equal to 3 by 2, then the work done by the gas in the process is what? Work done by the gas in this expansion process. Volume is increasing, right? So expansion process is what? So that is what you have to understand at a given temperature. At a given temperature. So the temperature value is not given in terms of T. T only you have to take. So options are, if you observe, they are given in terms of R and T. Okay. So you should remember that. What is the formula for work done in adiabatic process? We know that work done in adiabatic process is, W is equal to S NR into delta T or delta theta, any symbol you can use. NR into delta T by 1 minus gamma. You have to take it as 1 minus gamma or gamma minus 1 based on the proper valuations you have to take. If you are taking T final minus T initial, then you have to take 1 minus gamma. Otherwise, if you take T initial minus T final, you have to take gamma minus 1 also you can take. That you have to be careful. So now, so what is given here is a sample of 1 mole of gas at temperature T is adiabatically expanded to double its volume. So as I said, temperature is not constant. Temperature is constant means the process should be isothermal, right? Now at, let us say initially the temperature is T. At a given temperature, initial temperature T1 equal to T, volume is V1. Is expanded to double its volume means temperature should be different at this volume. That also you don't know. So you have to get the change in temperature, you should know this. Then you have to substitute. Okay. So for that purpose, you have to use one simple relation here. You can take, this is equation 1. Here you have to say delta T is equal to Tf minus Tt. Or first you have to take what is the relation between the given parameters and temperature. So you should know for adiabatic process, the one of the equations for adiabatic process is PV power gamma equal to constant, and also TV power, you have to take gamma minus 1 is equal to constant. So you can take T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. You have to take carefully. So here T1 is given as T, and T2 in terms of T you have to get, and V1 V2 are given in terms of V and 2V also. So T2 is equal to, you can further write this as V1 by V2 power gamma minus 1 into T1. So it is equal to V1 is V, V2 is 2V, power gamma is 3 by 2 minus 1 into T1 is T. So this, on simplifying, you can take VV cancel, 1 by 2 power 3 by 2 minus 1. 3 by 2 minus 1 is 3, minus 2 is 1 by 2. So 1 by 2 power 1 by 2 is, it is 1 by root 2. You can also take T2 is equal to T by root 2 is T2. This is your T2. Then that if you substitute here, then you will get work done. So equation 1 implies the work done in adiabatic process is N is the number of moles, 1 mole. For 1 mole, r into t2 minus t1, t2 minus t1 by 1 minus gamma is 3 by 2. Yes. So this, if you take here, so only the numerical values, if you want with the sign, if it is given, you have to take accordingly, otherwise for the only the numerical, I mean magnitude part you have to take. So let's take it properly. 3 by 2. So this is equal to r into t2 is t by root 2 minus t1 is t by, this is if you simplify this, 2 minus 3 is minus 1 by 2, 1 by 2 or minus 1 by 2 is this. You take this 2 to numerator, then you can write this is equal to minus 2r into t minus root 2t by root 2. This minus, if you multiply, then you will get root 2 t also you can take out, root t minus 1 into rt by 2 is there, right, into 2 by root 2, and this 2 you can also write it as root 2 into root 2 by root 2, so then you will get root 2. Here 1 root 2 you get. So here you have to simplify based on the requirements. Again what is that, options. Here r into t is there in numerator. Yes, r into t. So first and second option, third options are there. So second and fourth options you can what you call omit. So then which option is there? 2 minus root 2, 2 plus root 2 is there. Which one is that? This minus 2 is there. This, if you simplify with if you multiply with this you can write it as here itself. Well, simplification process, you can take like this. You can take minus sign, if you send here, it becomes rt into root 2 minus 1. Here 2 we can written as root 2 into root 2, root 2 into root 2 by root 2. This root 2 cancel, then you will get root 2 rt into root 2 minus 1. If this option is there, that is okay. Otherwise you have to take this as, you can also write it as rt into, if you multiply root 2, if you send inside, then root 2 to root 2 becomes 2 minus root 2. This is also correct. So based on this you have to select the appropriate option. So rt into 2 minus root 2, option 1 is the correct one. So this is how you have to simplify. This is very simple question. Okay, only thing is you have to follow properly. That's it. I hope it is clear for you. Next, let us go to the next question. Yes. So here, what is given and what you are asked to find. What is given and what you are asked